Hi, everyone, and welcome. My name is Liz Osterman, and I'm the Director of Visitor Experience at Chabot Space and Science Center. And tonight, we're really excited to bring you our virtual program in partnership with the SETI Institute. Tonight, we have with us Beth Johnson, who will be discussing alien worlds, exploring science fiction from science fact. And we have Simon Steele from the SETI Institute as well here with us to say a few words. Simon, thank you, and thanks for joining us.
Hi, thank you, Liz. Good evening, everyone, and welcome to our 10th and sadly a final Tuesday evening Talks for Families in conjunction with the Chabot Space and Science Center. It's been a great adventure, a great exploration of the universe, and we're going to end up with a fabulous last talk because we're going off to explore strange alien worlds. And you know, we've all got our favorite alien worlds, whether they're Tatooine or Pandora, or if you're old like me, there are great worlds like Altair 4 and Metaluna. Look them up if you don't know them, and go off exploring. These are all fantasy worlds, but what's amazing is that now through telescopes like Kepler and TESS, we know of maybe 4,000 or 5,000 real planets orbiting other stars. And the question is, how do they compare with our works of fantasy? Are we completely off the ball, or have we really predicted what these worlds are going to look like? And that's the tale of tonight. And so without further ado, thank you, everyone. Sit back. I'm really looking forward to this, and I'll hand back over to Liz.
Great. Thank you, Simon. A little bit about Beth Johnson, who is the social media coordinator at the SETI Institute, where she not only shares the news, outreach, and photographs of the Institute's work, but curates a wide variety of astronomy, space, and planetary news for other sources. Additionally, she is the communication specialist for the Planetary Science Institute, splitting her time between social media and web content production. She's also the co-host for the Daily Space Cosmos Quest daily news show on Twitch and in podcast form, as well as the co-host at the SETI Institute's Grudge Report, which covers science and science fiction television shows. Without further ado, we'll hand it over to Beth, and then afterwards we'll be taking Q&A from the posts in the chat. So make sure to post, and we'll pull out some Q&A for Beth. Thank you so much, and we'll hand it over.
Thank you, Liz, for such a wonderful introduction. Hello, everybody. Thank you for joining us this evening. If you are here on the West Coast, very late or much at night, if you're on the East Coast and elsewhere around the world, welcome. I am going to start my presentation. So here we go. Let's get the show on the road tonight. So we are going to look at forbidden planets, alien worlds in science fiction and science fact. So what I want to do tonight is I want to talk to you about what some of these planets that we have in our science fiction genre that we've seen in movies, mostly movies because the visuals are better than paperback form. And I want to talk about like how the science has turned out for some of these worlds. We've made a lot of discoveries in the last 20 odd years when it comes to exoplanets. And so there's a lot that we have learned since things like Star Wars came out. And even since things like Avatar came out. So there's a lot of information out there, and I want to bring some of that to you as much as I can. I've kind of got a little outline going, so let's see how this goes tonight. So we start out a long time ago in a galaxy far away, but actually, no, we're in our own galaxy. We're gonna stay here. We're gonna talk about planets that exist in other galaxies because of science fiction, but what we're really looking at is how those relate to the planets we have here in our galaxy that we've been finding over the last few decades. And of course, where else do you start but that iconic image of Luke staring out at two setting suns over the desert world of Tatooine? This is sort of that iconic image that we all have when we started thinking about exoplanets and what might be out there and how could we, could something like this exist? And I've always found it very fascinating that we didn't have answers for that. I mean, we have lots of ideas, and obviously we have a solar system. It has planets in it, so we know this can happen, but it hasn't happened elsewhere. And in particular, once we started finding planets, which was back in about 1991 was when we found, 1992 was when we found our first planet outside of our solar system. Very big deal. But what else is out there? You know, we've launched so many different telescopes now. We've launched Kepler, we've launched TESS, the Europeans launched Karot, and all of these have found planets. We're finding planets in direct images now. So what about this one? Is this possible? And it turns out, yes. So this is an artist's rendition, but this is the Kepler 16 system. It's a planetary system that it's one planet. It's a hot Jupiter, so it's close into its stars. But if you see, there's two stars in this image. There's a bigger yellow one and a smaller red one. And this planet is going around both of them. So for this planet, it would have two sunsets. That's pretty amazing. Not only did we realize that, oh, wait, we can have this kind of thing like Tatooine, but we actually found evidence. And it's not the last one that we found. There are others out there, but this is the one that really broke the mold for us, that said, yes, you can have a planet that goes around two stars. And that's pretty amazing. So I'm pretty excited to see that right off the bat. So what else do we know about Tatooine? Tatooine is a desert planet, right? We know that people are farming for moisture. There are lawless towns. And I was shocked to find that, you know, there are people that just are living there. It's a thriving civilization, and there's very little water on this entire planet. But it's not the only desert planet we have in science fiction. This image, of course, is from Dune. This is the new one coming out soon. All of us very excited. And this is the desert world of Arrakis. And I looked this up because I wanted to know more about this planet, because it's been a long time since I've read the books, and it's been a while since there's been a movie, and I'm excited for this one. There are 15 million people living on Arrakis per the fiction. 15 million people on a desert planet. And we all have those images of sandworms in our head, right? Both from Tatooine and from Arrakis. Well, could those exist? We haven't found any evidence of life, right? It's just us. But what's the possibilities? Well, it turns out, if you pay attention to the news a lot lately, we have a desert planet here in our solar system, Mars. This is a recent shot from Perseverance. This is brand new, just came out in the last week. And one of the things that Perseverance is there for is to look and say, can we have life on Mars? And there's been a lot of research that's come out just in the last year, that says that, yeah, actually conditions are still ripe for this. Mars once had water, but new research says Mars still has water. It's not really at the surface. There's subsurface ice that we can get to. We think we can get to fairly easily, but it's there. And if there's water, we know that life on Earth needs water. And we know that we have extremophiles that live in desert environments. There really isn't any place on Earth that there isn't life. Every time we go someplace and we say, no, there's not going to be life out here. No, there's life. There's life in the Atacama Desert in Chile. There's life at glaciers. There's life there's an algae that thrives on snow. There's life at the bottom of our oceans around hydrothermic vents, right? So we have all these possibilities for life. And it turns out that Mars could host some of these things. There's still that water. And then just in the last few weeks, we've had another paper come out that talks about how there might actually still be active volcanoes on Mars. Now, when I say active, I'm not talking about they happened yesterday, and if we look through our telescopes, we're going to see some sort of lava fountain. But they did happen about 50,000 years ago. And 50,000 years ago, in geologic terms, is the blink of an eye. If you took all of Mars's geological time and made it one day, that 50,000 years ago, that last volcano that we found that erupted, that would have happened in the very last seconds. I mean, that's amazing. And so if you have that lava, that magma that could be moving underground, NASA InSight's detecting some Mars quakes, and those Mars quakes could be signs of magma moving. It's in the same region as this fissure that was found that erupted barely all that long ago. But if you have that magma moving underground and you have that subsurface ice and liquid, those things could come together. You could warm up your water. You could have those, maybe some venting underneath, and you could create life down there. You could sustain life. It's very possible that life was there. I just went underground as Mars's water disappeared. And we're not 100% certain how that water disappeared. It could have left through the atmosphere. It doesn't have a lot of gravity. The atmosphere is very thin, but it could have gone underground and it's now trapped in the minerals in the rocks. So we have possibilities here. Now, do those possibilities include giant sandworms? No. Mars is too small for these huge dune or Tatooine-like worms that live underground. There just isn't the room for creatures of that size. That's not to say they couldn't be out there somewhere, but we don't have the evidence for them at all, and they're very unlikely on Mars. But desert worlds aren't the only place we're looking, right? We have other places, even here in our solar system. So let's look at the science fiction first. And now I'm going to take you to a little movie that we like around here called Interstellar. And Interstellar has a whole bunch of different worlds, right? There's several worlds. They're all at this black hole, which is a whole different thing I'm not even going to get into tonight. But one of these worlds is an icy world. This is the planet that Dr. Mann has, right? This is the one where he's living, and it's just icy. Now, we have those here. We have Europa. We have Enceladus. And science fiction is full of these. I mean, we have Hoth from Star Wars, of course. We have Rurapente from Star Trek. It's a prison planet, but it's icy at the surface. Everybody lives underground. In Hoth, they've built big fortresses to survive. You can see in this one, they've got a station where they're living. You can't, they're still in spacesuits on the surface. This isn't some place that you could walk outside and be happy as a human. But maybe there's life underneath, right? Here in our solar system, we have Europa. We have Enceladus. We have all these little icy moons. We even have Pluto. And all of these are thought to have these subsurface liquid oceans, right? Full of water. And they're heated up by various mechanics that aren't involving direct sunlight, which is frankly amazing. We think that we need sunlight and we need water. Well, what if you have one but not the other? Are there other ways to make these things happen? And the answer is maybe. I mean, we don't have the answers yet, but Europa has a subsurface ocean, and we want to go there and we want to find out, could we see signs of life? Could we detect something through this thick ice that it has? It's possible. You have the tidal heating from Jupiter. So Jupiter is squeezing the planets. You have the tidal heating from the other moons, right? So they're going around and they're pushing and pulling on Europa, and it's being pulled on by Jupiter. And so it gets heated up in the middle, and that allows this liquid water to exist under the surface. And we know that down at the bottom of our ocean, where it's not terribly warm, there are hydrothermal vents. And that's where we think maybe possibly life has started, definitely is there now. There's creatures that live on these vents, that live around these vents, that eat the metals that are venting out from these. So that could be happening on Europa right now as we speak. I don't think we're going to find space whales. I would love to find space whales. But I do think that we're going to find evidence of life, I hope soon, someplace else. But there's definitely a possibility here. So we could find life on icy worlds. And if they had the size and the atmosphere where we could actually, the gravity where we could wander around, yes, maybe we could build some sort of station on them and exist there. These are probably too small. I think your planets in science fiction are bigger, usually bigger, so that you can actually exist there. But it's possible. And now we're going to take you to a couple of worlds I find really fascinating. I'm not going to say these are great for possibilities of life, but it does go to show that they can exist, that the science fiction isn't as fiction as it seems, right? There's a science possibility here. So this is Mustafar. You have to keep bringing Star Wars in. Star Wars has so many really interesting fleshed out worlds. They have a budget and they can make the most amazing things. So this is Mustafar. It's obviously a very volcanic planet. It's basically a lava planet. And they've built a plant, right? You're getting all the geothermal energy that you could possibly want. I'm not going to say that there's any life on this. Basically, all we see are people that are visiting and the droids that they have working there. But it's a planet that's basically volcanoes. Well, that's interesting, but is it possible? And again, the answer is yes, it's possible. This is, and you can see from my background, which is the exact same image, this is my favorite little moon in our solar system. This is Jupiter's moon, Io. Io is the most volcanically active body in our solar system. It doesn't have plate tectonics like we do. Again, it's that pushing and pulling and squeezing from the Galilean moons and from Jupiter. And that keeps this little planet, this little moon, very heated up. And it erupts constantly. You can see in this image that it's erupting right there. There's a little eruption right there at the top. And it's always erupting. We've looked at it with different spacecraft, and we can find lots and lots of signatures of this little tiny moon erupting. I love it. It's in my necklace. It's behind me. This is my favorite body. And it just goes to show that yes, a world that is entirely volcanoes could exist. Now, you can look at that and say, but that doesn't look like Mustafar. This is true, but Mustafar had more of an atmosphere, so things could move differently, a little bit more gravity. Again, people could walk. Io is a tiny moon. It's covered in all of this. It's got a lot more sulfur in it than what we see in all of our images of Mustafar. So there's definitely a different composition to all of the lava that's coming out. And it's still really cool. It's not the prettiest moon. I'm not going to say that it is, but I think it's really interesting. I don't think it's a candidate for life. But again, we never know. We find life in a lot of weird places here on Earth. And speaking of life and worlds that are sort of flush with it, I've looked at these very barren wasteland worlds, right? We've looked at desert worlds, we've looked at icy worlds, and now we've looked at a lava world. These are all worlds where, yes, life is possible. Yes, humans in science fiction have managed to build some sort of civilization on them or outposts on them, whatever has seemed to work. But what about a world that really truly holds biological life? And where we've seen that in the movies really has been on forest moons. So this is the forest moon of Pandora, right? This is from Avatar. It's a very, very lush world. I'm not going to get into some of the other bits and pieces of it, but it is a beautiful forest world. We've also seen, again, coming back to Star Wars, there's the forest moon of Endor, the lush, thriving forest civilization. We have our cute little Ewoks, which some people don't like, but I like. And we have, people just walking around breathing air, no big deal. Pandora has its own civilization, its own culture. There's definitely life going on there. And the thing about Pandora that's really interesting to me is when you look at the fictional lore of this planet, it is a forest moon that is going around a gas giant that orbits Alpha Centauri A. So Alpha Centauri is a planetary system that is, well, relatively close to ours. It is in fact the closest system to us. So it would be Alpha Centauri, but it's a binary. So it's Alpha Centauri A and Alpha Centauri B. Oh, wait, no, there's one more. There's Proxima Centauri. And Proxima is so named because out of those three stars, it's actually the closest one to us. So there's three, and that one, they're about 4 light years away. So not close, but close-ish. And in this case, James Cameron came up with the idea that there's this forest moon orbiting a gas giant around Alpha Centauri. Cool, right? But fiction, except maybe not fiction. Now, this is a picture from a science paper. It's direct observations. So you can see that the star has been blocked out. You can see both stars. Here's Alpha Centauri A, here's Alpha Centauri B, here's sort of the center of them. And then over here, what they fleshed out is this candidate 1 star, or candidate 1 exoplanet. It's a possible exoplanet. This is also a recent thing from this year. They've been trying to find planets around Alpha Centauri A and B for years now, and they've had some possibilities, but this is the latest. And they're thinking this one right here is a possibility. It's candidate 1. It's maybe about Neptune to Saturn, half of Saturn size. So not quite gas giant, but ice giant maybe. So very close to what we're talking about when we think of Pandora, orbiting the right system. And while we don't have the ability to see exomoons yet, there could be exomoons. And we do know that there are at least 2 planets going around Proxima Centauri. Now, Proxima Centauri is a different type of star. It's much smaller. It's much more violent. And the 2 planets, while they are in what we would think of as the habitable zone, where liquid water could exist on a planet, there are a lot of solar flares from Proxima Centauri. So there's back and forth about whether or not life could exist on either of these planets. And, right now, we can't even see if there's a moon around this candidate planet. We haven't even confirmed that it is a planet. It's a possible planet. But maybe someday we can find some exomoons. And maybe someday we can see if those exomoons have a way of heating up, sort of like how Io does, sort of how Europa does, but maybe a little bit better, a little bit warmer, and maybe have life on them. So again, still a little bit in the science fiction, but the possibilities are there. We continue to make discoveries that make the science fiction not just fiction, but science possibilities. And we're not yet to science fact on some of these, but the facts are there. It's amazing that the art is being found in life, right? Normally we say art imitates life, but it seems now that we're at the point of life imitating art. Like we have devised things, we have dreamt up things, and now we just keep finding them. So the next one is a special one for me, and maybe for a lot of you watching. The next one is kind of a big system. It's a lot of planets. This is the Firefly Serenity planetary system. There are multiple star systems going on. There are a ton of planets, and they range from rocky planets to gas giants. There are extra stars going around. You can see there's the one star right here, and this is another star, and this is another star, and they have planets. There's orbits within orbits going on. It's very, very complicated. And while we haven't found anything quite this wild and all-encompassing, one of the biggest discoveries that we have found is that there are multiplanetary systems out there. And it's not just 2 or 3 or even 4 stars, right? We found those too. But we found the TRAPPIST-1 system, and that one has 7 stars. And if you look at this image, you can see that some of these look like they could be rocky bodies. And some of them, a lot of them actually, could be within the habitable zone, that Goldilocks zone where liquid water could exist. Now, I want to step back a little bit and take a brief moment to talk about this concept of the Goldilocks zone. The Goldilocks zone is sort of a misnomer. It's what we've been calling this area around a star where a planet that was orbiting in it could heat up enough just from the light of the sun, just from the energy produced by that star, to have liquid water on the surface. That's really what the Goldilocks zone is. It says nothing about anything else. It is literally, it is in a location around a star where it could have enough energy from the star alone that it has liquid water on the surface. That's a lot of qualifications. It's a very specific definition. So when we say Goldilocks zone, we don't necessarily mean that all of those things are happening. There could be other factors involved, right? Your star could be flaring a lot. Your water, there might not be enough atmosphere. It might not be big enough, right? There could be anything. There's a lot of possibilities that go into this. So we're not saying this is a zone where there is life for sure. We're saying this is a zone where, all things being equal, humans, life like humans that depends on sunlight and water, things on our planet that have that capability, could possibly exist there if the conditions were right. That's why when people get very upset about the term Goldilocks zone, I like to say, yeah, we know. We know. We can look at our own solar system and say, well, technically, Mars is within the habitable zone. Venus is within the habitable zone. They're at the edges of it, but they can have liquid water. But there's a whole bunch of other factors in there that led to, well, yeah, but no life. Maybe not. I mean, last year showed us that Venus is still a possibility in people's minds. Mars is definitely a possibility in people's minds. So we don't want to rule out things too quickly because we've been proven wrong before. Again, life seems to exist wherever we can possibly find it. There are tardigrades, little tiny water bears, microorganisms that have been found living on the outside of the International Space Station in basically microgravity, right? It's not quite the vacuum of space, but they are in microgravity. And they're happy, they're just living out there. So we keep finding life in wild places. So why not any of these particular worlds? It's pretty exciting and pretty special. And every day we keep finding more and more planets, more and more ways. As Simon said when we started, we've got 4,000 to 5,000 planets we've said are out there right now that are in our galaxy, but not inside our own solar system. That's pretty cool. And as our technology gets better, as our telescopes get bigger, as we start doing things like advanced adaptive optics, which is where you find a way to manipulate the shape of your mirrors to account for things like water moisture in the air, right? If you've ever looked through a telescope from here on Earth, and you look up at the sky and you look through your telescope, sometimes you'll see that shimmer, that waver of whatever it is you're looking at. And that's the water, the moisture in the atmosphere affecting your view. And it's really hard to get a good detailed image. If you've done any astrophotography at all, you know this is the case. You have to stare at something for a long time, and then you have to do a whole bunch of processing to make sure everything stacks nicely, and then you get the nice clean image. That makes it doing science very time consuming. So one of the ways that we've done that is we do adaptive optics. And what you do is you basically use a laser, you point it up at the sky, and you say, okay, that's my star. That's the star that I'm looking at. And because it's in our atmosphere, it's within our atmosphere, it's a very fine, sharp point. And then you design your mirrors so that they can be flexed, right? So instead of just being one flat mirror or curved mirror, you have pieces. And they can be rearranged, they can be shifted just a little bit, just enough, not like this, but like, right? And it can clear up your view. And now you can take pictures of things from here on Earth that before we needed to use things like Hubble to take pictures of. And that includes direct imaging planets, like we did kind of back here, right? This is from stuff taken here. That's amazing to me. And there's quite a few of these. I will always recommend the Gemini Observatory because it has the Gemini Planet Finder. One of our own scientists here at the SETI Institute, Frank Marchis, works on that project, and they have taken direct images of exoplanets. So we've spent time talking about exoplanets, and we've talked about science fiction, and we've talked about how science fact gets involved. But what about the planet you're standing on right now? All of these worlds in science fiction, all of these worlds that we've discovered, they don't have us. There's only one planet that has us. There's only one planet we for certain know of has life, and it's the one you're sitting on, standing on, or laying on right now, right? This is the only place. And we don't have ways to get to these other worlds yet. Mars, we haven't figured out how to exist there. There's still a lot of things to learn before we could possibly set up shop like in The Martian, right? For all that The Martian is full of really great science, we're not there yet. That's why it's science fiction. But we do have life here on Earth. And there are a few movies that talk about that too, and talk about the ways that we have to be careful. So when we go to explore other planets, maybe you've seen this, maybe you've heard about this, we have clean rooms, right? You see everybody in their very white suits with the helmets, and we call them bunny suits, right? It's the same thing that you do when you build computers. You don't want dust, you don't want biologic particles. You want to keep your spacecraft, and especially your rovers, as clean as possible, because you don't want them to get some sort of false signal, And you don't want to basically spread Earth life elsewhere. That's a possibility and a concern. So we don't want that. But we do have some movies that we do have several movies that take a look at what happens when these things occur, right? So kids, don't watch this one until you're older. This is The Thing from 1982. That's Kurt Russell. Some of you might know him as Santa Claus. Some of you might know him as Snake Plissken. There's a whole bunch of things. But in this case, this is a movie where there's an alien parasite and it infects people on Earth. It's a horror movie. So it's science fiction horror, sort of along the lines of Alien and Aliens, right? This is not a kid's movie, so be careful. But it is something we have to be cautious of, because not only do we have to be concerned about taking life forms to other planets, we have to be concerned about bringing life forms back. We're doing a lot of asteroid recovery missions, right? We're going out, we're bringing back rocks from asteroids. So we have to be very careful that if there's life in those samples, we don't let something happen to it or to us as a result. Now, the chances of there being life in those asteroids, still kind of thin, still kind of marginal, but not necessarily impossible. So this is one of those things where we have to be careful. So this is where I talk about planetary protection for Earth. Also, again, we apply this to things like Mars and to the moon. We make sure that we don't send things there that are compromised, that could cause a problem later. But really, the main point I want to bring home at the end of all of this, at the end of all of our exploration of all these different worlds, and there are so many more out there we could have talked about, so many more. But the big thing for this one, and I'm going to finish it off with Wally, is remember, we have to take care of the world that we're sitting on right now. This is the one we have. We're not going anywhere anytime soon. We haven't solved a lot of the problems that would help with that. And besides which, not everybody could go. So we need to take care of the planet that we have. There is no big corporation that's going to save us with a spaceship and send us off into space and meet all of our needs in somewhat horrific ways, but still comically Disney. There's no little army of robots that's going to try and clean a planet we have destroyed. We've got to take care of this one now. So on that note, I want to wrap it up and say, while you're looking up and you're looking up at all those stars and you're thinking about those planets out there that exist around other worlds, and you're dreaming up our next great science fiction story, which please dream up our next great science fiction story. That's why these do well. We love these stories. But remember to look down too and appreciate what you have now. Because as Carl Sagan says, this is our pale blue dot. And we've got to take care of it. Thanks, everyone.
Great, thank you so much. That was a fascinating presentation. And now if everyone would love to post any questions in the chats. We have one that from Charles that says, do you understand that it would be easier and cheaper to create artificial habitats in the Sahara or Gobi deserts than on Mars, even in northern Russia or northern Canada?
Absolutely. Again, we haven't really solved many of the problems for getting to Mars with people, let alone living on Mars. We haven't even built a place to live on the moon, and we have a much longer understanding of what's going on with the moon than we do with Mars, right? We've been there. We've brought back rocks from there. We know that we have problems to solve there. That the dust, the regolith on the moon is ridiculously sharp, and we have to start with that, right? That's a lot of the conversation is, well, we want to start there. We want to build that place to launch off from. And people are talking about Mars, and it's like the soil's unfriendly. There's no atmosphere. There's not as much gravity. Not no atmosphere. There's very little atmosphere. There's a lot of carbon dioxide. There's no liquid water at the surface. We don't know if we can get to the subsurface water supplies. There's a lot of things we still have to solve. We're working on it. Perseverance has an instrument on board called MOXIE, and it's a technology demonstration to try and create oxygen out of carbon dioxide on the surface of Mars so that you don't have to bring all of the supplies with you. Like, this is what we call in situ resource utilization. And that means that we need to find a way to use the stuff that's there, because rocket fuel is expensive, and anything that you try to move from point A to point B has to be accelerated out of our gravity well, and that costs fuel. So if you want to come back from Mars, you've got to do the same thing in reverse. Now, Mars's gravity well is smaller, but you still need more rocket fuel. So you can either bring it with you, or you can find a way to make it on the planet. And oxygen is one of those things that we use for rocket fuel. So MOXIE is proving that you can break apart carbon dioxide into carbon monoxide and oxygen in place on Mars. So yes, maybe one thing solved. But you're right, it's absolutely easier to do sort of Mars analog research here on Earth. We have research stations at Antarctica, we have research stations in Chile, we have research stations in the Arctic at Devon Island that are all sort of Mars analog sites. And while it is difficult to live there, you can live there. And you can do so without a lot of fuss. So yes, to your point, we have not solved Mars. It's much easier here on Earth so far. And that's why we're kind of stuck here.
Great. We have another question from Ron, who says, why has not NASA built a rover that can drill down into the ice layer in various areas of Mars? I know that several rovers already have drills, but they do not seem to drill down very deep.
So InSight had what we call the mole, and it was supposed to drill down. It was supposed to drill down pretty far. I don't remember the exact number off the top of my head. Unfortunately, the soil on Mars turned out to not be quite the consistency that we needed it to be. So again, there's no way to solve that. You know, we can't fly, we can't go there and determine some other method. We have to use what we have. So they spend a long time with InSight trying to get this mole to actually dig underground, and they did everything they could. They used a different tool on InSight, a shovel, to basically like push down on the drill so that they could kind of like give it that extra bit of grasp to push down, and it just didn't work. So they gave up on that recently, unfortunately. It is obviously something that we want to try, but it looks like we're going to have to go not necessarily back to the drawing board, but there's revisions to make on the process.
Great. Are there any more questions? Go ahead and post to the chat.
Did you have any questions, Liz? Was there anything you wanted to ask me?
Yeah, I actually wanted to see what lights you up the most. What are you most excited about in terms of exploration at this moment?
I think the last few weeks have, up till now, I would say, oh, I'm looking forward to the Europa mission. You know, I'm really excited about, sending something to Europa and really taking a look there. But the last few weeks of science news from Mars, I'm a Mars fan now. I think we have a lot of prospects there that I might not have agreed with a few months ago. I would have said, what's the evidence? But now it's like, well, we're mapping water ice reserves underneath the surface. There's possibilities that, there's magma moving underground. It could be interacting with this water ice. Could have pockets of places where life could exist that was on the surface and now is subsurface. We have Perseverance looking for those things. We're finding evidence of water, of sedimentary structures. I mean, it's just amazing what has come back. And Percy hasn't even really started its science mission yet, right? Percy has just been babysitting a little Mars helicopter named Ingenuity. That's been its job for the first few, it landed in March. So it's the first couple months has been basically, here's a little tiny helicopter. We're going to try and make it fly. You have to stick close because it can't do stuff on it. It doesn't have a camera. It can't, we can't see what it's doing. And now they're like, okay, well, we've successfully flown it 5 times now. We're going to do other stuff with it. Percy, you get to actually do your science. So we haven't even gotten science results back yet. So we're 2 months into a mission, and I'm now wickedly excited to see what comes of this, really. So it looks like I've got a question from Facebook that says, why is the carbon element so fascinating? Oh, his kids asked. Oh, okay, Sean, for your kids, why is carbon so fascinating? Well, one of the reasons is when we talk about organic molecules and things that make up life, we are what we call carbon-based life. I'm going to say this with a caveat that I'm not a biologist, but most everything here on Earth that is life is carbon-based, right? All of the molecules, all the proteins, those amino acids, everything has carbon in it. Any organic chemist will cry at you about how they had to take OChem. But so when we talk about why it's so fascinating, why we need it, that's why. It's our life is literally based around it. It's one of those things that we say we have to have for life, simply from what we know. Again, we have a sample size of one planet with life on it. And so it's just a life here that we can really base our theories on. We could find something wild and different, but in the meantime, it's got to be carbon based. That's what we know. That's how we know to detect signatures from it. So that's what we're looking for. Does our sun, so from Facebook, from Daniel, does our sun show any evidence of being a variable star? No, it's a nice steady star with a nice steady solar minimum, solar maximum cycle. We've timed it down to 11 years. It's not particularly variable. It doesn't flare, and thank goodness, because flares are bad for us, folks. We have to watch for those. You get those coronal mass ejections. They can take out our tech. They can take out our satellites. They can take out our GPS. They can take out our communications. They have been known to do so. They did wipe out, they caused a power outage in Quebec sometime not all that long ago. And so, we should be thankful that our star is the boring star that it is.
We also have a question. Richard was wondering why we haven't put a probe closer to the poles or the ice caps.
Oh, of Mars? It's a very difficult insertion is the problem. China has been talking about it. There was a Mars polar orbiter, Mars polar lander. It was not a successful thing. It was not a successful thing. So it's a very difficult place to get things inset, because of course we're spinning on this axis basically, right? And Mars is spinning on the same axis. And so when you launch something from Earth, it's kind of going out along that field to get to Mars. It has to kind of go along this one plane to get there. And then what you're trying to do is you're trying to flip it up and around, basically, if you want to probe. And even if you want a lander, you're still going to kind of have to do the same thing. So it's very difficult to do and requires probably a little bit more fuel than we've been willing to spend on the process.
And then we have another question. How close are we to actually start to travel to these planets?
Not very. I'm going to be honest, not very. There are people who are trying to make some breakthroughs in traveling to other worlds. There's always that wonderful science fiction talk of how we would do it, but nobody's actually really mastered faster than light travel, subspace travel, hyperspace travel, whatever you want to call it. We don't have it yet, and so our farthest reaching spacecraft have just left the solar system, and they were launched 45 years ago ish. So yeah, we're not there yet. I think the fastest thing we have in the spacecraft is the Parker Solar Probe, which is heading towards the sun, and it is going 0.05% the speed of light. So 0.05. So we're not even at 100th the speed of light yet. So yeah, we're not there. Do we have any other questions? Simon, did you have anything? You're quiet back there.
Yeah, I'm quite sorry. My headphones and everything was off. I suppose a couple of we've been talking about Earth-like planets so far, even if some of them are icy and some of them are moons and some of them are deserts. These are all terrestrial rocks. How far would you push the envelope as far as life in the universe? Are you willing to consider giant floaty things in Jupiter?
Well, I think with all of what has gone on with Venus and the possibility of phosphine in the atmosphere, however that turns out in the end, it has definitely inspired me and more people to say, well, maybe we haven't covered all of the possibilities. And not only did they come up with a reasonable mechanism for why these creatures, like a creature that would put out a phosphine signal, could exist in the cloud layers of Venus, it was reasonable. And so I think at that point, if you can say, well, we could do this in Venus, I think we could find places where we could do it in Jupiter and Saturn. They're obviously going to have to be much further out. Again, Jupiter and Saturn, being the gas giants they are, the gravity is very excessive, but it comes back to any way that we seem to imagine stuff, we continue to find it.
Yes. And another question about carbon-based life forms. I think there aren't many. I think there was a Star Trek episode where we had a silicon-based life form, the Horta, which was just fascinating. And but in as far as we know, carbon chemistry is the only way we can build complex systems. And so there is something amazing about carbon. And when people say, why are you looking for things similar to us based on carbon? The answer is we really don't know how else to do it as far as building life forms. So that's just that's pushing the envelope as well.
And I know there are scientists out there who are trying to find ways to recognize other life. We know what a DNA signature looks like, like if we saw it in a cell, we could say like, oh yeah, that's DNA. But what if they didn't have DNA? What if it was something else? And so I know there are some scientists who are really trying to push that edge and see if they could find ways to define life that wasn't DNA, wasn't carbon. So it's a fascinating thing. I'm not sure where it goes. Again, not a biologist. But yeah, it's pushing the envelope. And again, it leads to some really fascinating science fiction. So all the more reason to do it.
Yeah. And there is one other, of course, silicon-based life form, and that is robots and artificial intelligence and the possibilities that advanced life forms can actually build, constructions around their planet and things on a planetary scale, and that has come up in science fiction as well, and that is an active research activity for some.
There were a lot of things that you and I looked at when we talked about putting this presentation together that, I mean, we could take a very long trip down the world of silicon-based structures and life as far as artificial intelligence and robots. We talked a little bit about possibilities of ring world, of structures that we build that we can build out in space and they can be habitats. That's the same thing as like the Babylon stations in Babylon 5, right? They're all rotating, big, huge space stations. We haven't solved the problem of artificial gravity, so that's still definitely in the land of science fiction. But there's also the whole concept of the Dyson Sphere. Could we find that? Is that something that a civilization could build? We've had a few instances where we're like, oh, what's happening with this star? And everybody goes, it's a Dyson Sphere. And we all go, is it? Is it though? It's always dust. Like I'm going to say right now, it's never aliens until it's aliens. It's usually dust.
Yeah. Just like in the house. Up in space, it's dust is the primary culprit for most things. Yes. Maybe that's a good point to leave. Beth, if you had to choose a planet to live on, do you have a favorite? It can be real or imaginary.
Real or
do you want to build your own? Why not?
Honestly, if I it's going to be obscure for some people, but I know, Simon, you'll understand. I would live at Fern. And Pern gets to cross the line of science fiction because there's some science fiction elements to it later on in the series, but there's dragons, and I want to live on a planet with dragons.
And dragons, that's reasonable. Yeah.
I mean, if I have like the whole gamut of science fiction,
I didn't put any constraints on that. Whatever you want to live there, it's fine. Beth, I'm going to hand back to Liz now. Thank you.
Yeah, if you have time, we have just one last quick question. It was
sure, absolutely.
Saying, do we understand enough about our magnetic field changes to determine any future planetary risk? And can a change or fluctuation timing be predicted?
Oh no, magnetic field questions. I may have to deflect this one back to Simon because magnetic fields are not my area of expertise at all. They scare me.
Could you say it again? I did the question. As he stalls.
Yeah, so it says, do we understand enough about our magnetic field, the changes in our magnetic field, to determine any future planetary risk? And can the change or fluctuation timing be predicted?
So the magnetic field from Earth does show a history of shifting and changing, and that's recorded. Of course, there are ferromagnetic rocks that act as a sort of a history of how the magnetic field on Earth changes, and it's known to have flipped poles, and the pole itself wanders a little bit. The question is, when do these poles flip? How long does it take? And what the effect has is still unknown. We rely, of course, on our magnetic field to protect us, because it protects us from some very nasty high energy particles from the sun. And this protection is something, say, that Mars doesn't have, because Mars does not have a global magnetic field. So it's a serious concern. We should be very thankful to the magnetic field that we have, because it is one of the things that has allowed life to flourish on Earth for a long, long period of time, and something that Mars, has struggled. May well have had a magnetic field in the past when it had a liquid, more of a liquid core, as a dynamo, as the liquid iron rotating as the planet rotates. But I'm not a planetary scientist, so I really don't want to push it any further than that. But there is certainly evidence that the magnetic field does change over time, and how, if it changes dramatically, how that will affect life is a very good question. Obviously, it does not result in the extinguishing of life, because we're still here, so that's a good sign.
And we've seen this in the rock records for forever, so it happens. As far as the predictability of it, from what I remember of looking at the magnetic striking patterns for paleomagnetics, which is basically looking at the history of our magnetic field in the rock record, there isn't like a set timing, right? There isn't some sort of like very, okay, it happens with regularity. This is not an old faithful kind of situation. There are some people that will tell you there's evidence right now that we are kind of getting into that shift, that there could be a shift soon-ish, but no one really has any idea what the timescale is, or how quickly it happens. Like, does it happen like a snap of the fingers? So one of the reasons that, and I said I don't know a lot about magnetic fields, apparently I'm lying. One of the reasons that we have coronal mass ejections on the sun is because the magnetic field lines, the sun doesn't rotate at the same speed at all of its different latitudes, right? So different parts of it rotate faster. So the magnetic fields get twisted up and you get these sunspots. And then sometimes those sunspots get so twisted up and so big that they snap the magnetic field lines, and this causes that coronal mass ejection. So that's what can happen when those things occur. That doesn't seem like a really good thing to have happen here on Earth, but Earth doesn't rotate at that same differential. So our magnetic fields aren't going to get twisted up like that, but they are getting twisted up in such a way that they will eventually flip. And I believe someone told me that, I think I heard this from another astrophysicist, that our North Pole is actually south right now. So as for where our alignment is, technically our North Pole is south. So yeah, it's kind of, I don't think it's happened in humanity's lifetime, so that could be a really challenging thing to figure out.
Well, awesome. Well, I think on that note, thank you so much, Beth, for the fascinating talk and for answering questions today. And thank you to the SETI Institute and Simon. We've had 10 really fascinating and wonderful presentations, and we will continue the partnership in the future. And yeah, this was a lot of fun, super informative. And I just want to remind everybody that the SETI Institute and Chabot Space and Science Center are both nonprofit organizations. So if you'd like to donate, go to SETI.org or ChabotSpace.org and donate. And keep tuned in to both organizations. A lot of really great stuff happening in science right now. And we're so happy to partner with SETI to present it. So thank you again, Beth, and thank you, Simon.
Thank you for having me.
Yeah.
Have a good evening, everyone. Thank you.
Thank you.
Bye.